Hi, today I'm going to be doing virtually the educational Codeforces round 145. But today my strategy is to do C, D, and E because I'm usually spending a lot of time on A and B and like completely missing out on those. So let's see how this goes. This is a bad idea. Oh, 4 people already. Wow. Interesting. So I just read the question. Let me try to explain what it is. So you are given an array. I mean, you're not given an array. So you're given integers n and k. You need to build an array of size n, right? Such that, so if it's size n, how many subarrays can it have? The way they've defined subarrays, you have some L comma R value. So if you start your subarray from here, you can have n minus 1. I mean, sorry, you can also end it here. So you can have n different subarrays if you start here. And then here, if you start here, you can have n minus 1 subarrays. If you start here, you can have n minus 2 subarrays all the way till 1 subarray. So you can have total of n into n plus 1 by 2 subarrays, right? And they'll give you a number k, which is 1 less than equal to n, k less than equal to n into n plus 1 by 2. So this means, and what you need to do is design an array such that only k subarrays have a sum that is positive, and all of the other subarrays have sums that is negative. So no guys can have a 0. No subarrays can have a 0 sum. Interesting. Yeah, no subarrays can have a 0 sum. And the constraints are you have 5,000 test cases, and the size of each of these guys is 30. So obviously, like, so this is T, and this is N. So I think we should be able to do like an N square solution worst case. Yeah, I think worst case N square is okay because that is 5,000 into 900. That's like 5,000 into 1,000. That's like 5 into 10 to the 6. Yeah, I think we can do an N square solution. Okay, so what are the ideas? Okay, I guess first let's just try to come up with arrays for the examples. So the first one is 3, 2, an array of size 3 where only 2 subarrays have positive elements. Okay, let me say this is, oh, yeah, okay. So let's say 5 minus 3 minus 7. Does that work? So from here onwards, every subarray will have a negative element, so we don't worry about these guys. But for this, we have, this is positive with itself. And this plus this is positive, right? But this plus this is negative. So this should work. So 1, 1 and 1, 2 are positive. And 2, 2, 2, 3. Sorry, 1, 3, 2, 2, 2, 3, and 3, 3 have negative sums. Okay, so that automatically gives us a strategy for whenever k less than equal to n. So for k less than equal to n, you could just have the first guy be positive, like a really high positive number, like say n, right? And so for a 7 size array, you can have this guy to be 7 minus 1 minus 1 minus 1. Until you want, until k. And then you could have whenever you don't want minus 7, for instance, so that it's too big. 1, 2, 3, 4, 5, 6, 7. Yeah. So these guys will all be positive, and these will be negative. Okay, so gives us a strategy for k less than equal to n. What about for, I guess, okay, thinking the same way, for k less than equal to n plus n minus 1. So k between, okay, maybe I should say n less than k less than equal to this. So now what? Um, I think you can use the same idea, make this positive, make this positive, and make all of the guys afterwards negative, and make whichever you don't want sufficiently largely negative. But the issue is, okay, these guys, okay, it's not that easy. And this is this direction, like you have to also think in another direction before we try to code this up. But okay, let's go through with this. The idea is, since you need at least n, so they can't be, okay, this is weird. They have to be lesser than 7, but larger than 6. And by how? It's a bit confusing. So for instance, if n equals 7 and say k equals 10, okay? So let's say I start with 20, then I know I need to put something here. I'm putting -1, -1. It's 1, and I need to be putting some negative numbers here. I don't know what those are. Okay. So for instance, if I put 10 here, these guys should be like -9 because we want the next thing to be negative. -1, -1. Yeah, this should work. Right. So now what happens is, okay, one sec. I want to ensure I'm sticking to time. So it's 9:20. Okay. Let me look at the code for system. 146 remaining. Till 140 remaining, I'll continue working on this idea. Well, I mean, 1 hour, 40 minutes, and then switch ideas. Right. Okay. So this obviously positive, 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 positive. Life is good because all of these can't negate 30. Oh, in fact, it has to be. And these, so I get 1, 2, 3, 4, 5, 6, 7, plus 1 from the 10, plus another 1 from here, plus another 1, and that's when I get a negative. And that's good. Okay. So I just need to place but the issue is if, for instance, I had and k is equal to 9, and I put the -9 here, this subarray would add up to 0, and that's not allowed. So yeah, it's these annoying cases that have to be taken care of. But it should translate pretty easily to the next case. For instance, if um yeah, I guess I'm saying, so I need to think about what to put here, what to put. But for instance, if I have so for the next case where k is less than k less than equal to n plus n minus 1 plus n minus 2. So for instance, 7 plus 6, 13, k is 15. 15, right? So then what I would want to do is say 30, 20, 10. Minus 1. Minus 10. Minus 1, minus 1. Yeah. So everything starting here is positive, so that gives me 7. Everything starting here is positive. That gives me 6. Starting here, this is positive. This next one is positive. And then here on, it's negative. Okay. Yeah, I like the strategy. And I guess I like the idea of going in multiples of 30 because 30 into 30, I mean, sorry, multiples of 30 seems fine. Yeah, because worst case 30 into 30 is, oh, sorry, not multiples of 30. Did I know? Yeah, I can just in general do that, I guess. Because, yeah, 30 into 30 is 1,000, that's fine. But what number do I put here that is never problematic? Feels like I just need to sum up whatever I get from like where I placed it finally to this position. So for instance, here I placed 10 finally, right? And I sum this up, I get -9. Then I do a -1 and I place it here. And the rest of the array is all -1s. For instance, now if we wanted all subarrays to be positive, um, okay, now, yeah, I think I'm happy with this. Idea, any thoughts? Yeah, I just need to think about how to implement it. I'll be like back in a jiffy. Okay, so I'm back. What are the edge cases we need to potentially worry about? Wait, first, what number? Oh, okay, we said we're just adding this. We don't need, yeah, this. Okay, let's figure out the details as we go. Looks good to me. Um, int n comma k. Okay. So sorry, vector int v. I guess while next um bound, yeah, bound plus equals next. Um might be useful to have a lower bound as well. While next lower bound is equal to upper bound. So if k less than equal to upper bound, then extra is equal to k minus lower bound. Right. So what this means is based on the step, if I'm at n, for instance, v of 0 gets a number. If I'm at n minus 1, v of 0 and v of 1 get a number. So for I in range 0, comma, n minus next. For int I equals 0, I less than yes, next I plus that. Okay. That's cool. That's cool. That's cool. That's cool. Now, the extra. How do you code that? So n minus next gives me this value. N minus next plus extra minus 1. V of n minus x plus extra minus 1. V of n next extra minus 1 equals minus val minus of val plus extra minus 1. So seems super complicated. But yeah, what happens if extra was 1? Then n minus next here would be 2. 2 plus 1, 3 minus 1 would be 3 minus 1 would be 2. It would come here, which is what I want. And this would become val So then if extra greater than 1, otherwise you can chill. No, I think I'm getting something wrong. You'll never have extra as 0. If you have extra as 1, you want this to change, right? Okay, yeah. n minus next, which is 2, plus extra, which in this case is 1. Yeah. V minus val, which was whatever, minus of extra minus 1. Yeah. Okay. Oh, So k less than equal to upper bound. K here is 2 less than equal to upper bound, which is 3. That is true. Extra is equal to k minus lower bound, which is 2. That's good. Extra is 2 for I equals 0, I less than equal to n minus. Next, less than equal to 0, which makes sense. I plus plus. Val minus equals 30, so 900. Val if I equals val. That's good, so that's a 900. N minus next plus x. V of 2 equals something. Oh, next minus minus. Ah, I see. With the ugly code, what up? Okay, let me just try dot slash a dot out. One test case. 900 minus 1, 900 minus 900, which is what I wanted, right? Okay. Minus 1 minus what I want. I think this is the one. Okay. I expected having to check for. Oh, okay, fine. Extra equals k minus lower bound. But in this case, it is equal to 2 rather than 0. Mod next is fair. I think mod next. Because Yeah. I feel like this would be impossible to debug. If this works. But I don't think it will. Feel like there will be something I missed. Oh, okay. Okay. I don't know if you guys saw that, but it got accepted. So that's good. The next problem, just read it and try it. Binary string sorted. You're given a binary string as consisting of only characters 0 or 1. Choose two consecutive elements and swap them in order to perform this operation. You pay 10 to the 12 coins. Nice. Magic where just occurred to me we're able to do transactions because we only ever need to deal with the log of the actual amount. Like each transaction takes a value log of the actual amount. Like if we had to pay 10 to the 12 coins, we actually had to go make 10 to the 12 changes, we'd be so screwed. Interesting. Choose any two consecutive elements and swap them. You pay 10 to the 12 coins. Choose any element from the string and remove it. You pay 10 to the 12 plus 1 coins. Okay. Task is to sort string S in non-decreasing order. Something about this 10 to the 12 and 10 to the 12 plus 1 makes me feel like see, you would only, okay. You would remove if you could. You would do one remove if that would save you two swaps, right? Two or more swaps. So maybe that plays a role because the 10 to the 12 is ridiculous, right? What they're trying to say is the removal is just slightly more expensive than the swap. So really you don't need to be thinking about, yeah. If a removal saves you a swap, do it. Or does it make a difference, the fact that it's so close? I don't know. Oh, okay. Okay, the question is when would you ever prefer two swaps over one removal? I don't think so with the array sizes. Yeah, you would never do two swaps over one removal. Okay, your task is to calculate minimum number of coins required to sort in, okay, fine. 10 to the 4 test cases. The sum of lengths of all string doesn't exceed 3 into 10 to the 5. 3 into 10 to the 5. So even if you swapped everything, yeah, no, that's not, that doesn't make sense. Okay, I'll just state the question for a bit. So you're given a string like 0, 1, 0, 1, 1, 0, 0, 1. You have to transform it 3, 4, 5, 6, 7, 8. You have to transform it to a string like all the ones on the right, all the zeros on the left. The only ways you can do it is you can perform swaps, or swaps are between consecutive elements. Oh, only, yeah, swaps are only, obviously, otherwise you would. Okay. So swaps are between consecutive elements, or you can remove elements. This, I mean, you can make it this, or you can make it any substring of this. Now, swap costs you 10 to the 12. Remove costs you 10 to the 12 plus 1. Oh, sorry. And what is the minimum cost with which you can transform? Now, I guess there's an easy upper bound to this minimum cost, which is remove all of the annoying ones. So in this case, remove this, remove this, remove this. So you get 0, 1, 1. Oh, and you have, the time you have is, oh, sorry. It's 3 into 10 to the 5 strings. So I think ideally we do it in O of n or O of n log n. Okay. So the easy thing to do is just, okay, one solution is obviously remove all violating bits. So for instance, in this test case, 1, 0, 0, we can convert it to 0, 0, and we use 10 to the 12 plus 1 coins, right? Versus we would definitely have to do 2 swaps, which is bad. Okay. Now, when would you not want to remove all violating bits? If you can replace any removal with a swap, right? Oh, okay. Is it true that both a swap and a removal will only improve, only get rid of one violating bit at most? I think that's a fair claim. 1, 0, 0, 1, 1, 0, 1. Violating bit. This. Actually, how do I know? When I see 1, how do I know if it's a violating bit or not? Oh, it's not clear. Okay, even that is not immediately clear. Like, for instance, I mean, the smallest number is not clear. You can't greedily go and do it, right? Here I could consider 1 violating, but if the rest of the string was 1, 1, 1, that wouldn't be. Okay. So that's not clear how to compute. Um, oh, I see. Okay, yeah, maybe let's solve an easier version of the problem. Okay, let's divide into 2 easier versions. Like if you could use only swaps, minimum cost using only swaps, and minimum cost using only removals, right? Okay, so what would be the minimum cost using only swaps? I guess I'm sure this would have been. Yeah. Um, you already know which guys have to be 0 and which guys have to be 1. I don't know if you save up by going to the closest zero location or not. So mm, yeah, I guess even with just zeros, I mean, just swaps and just removes, it's not a trivial problem. And now we get to do both. I think the number of swaps is equal to the number of inversions. I think you can prove that. One is fine, zero. So that's one inversion. This is fine, this is fine. Zero, three inversions, four inversions. This is fine. So is the number of swaps equal to the number of inversions? And then, I mean, I vaguely remember something like this for bubble sort, but let's see. So I must swap this here. Okay. So first let me make two swaps. Two swaps, 0, 0, 1, 0, 1, 1, 1. Okay. And let me make two more swaps. 0, 0, 0, 0, 1, 1, 1, 1. I think that is true. Okay, I'll think about why later. I'll assume that's true for now. Or maybe I'll try it another example. 1, 0, 0, 1, 1, 0, 1, 0, 0, 1, 1, 0, 1. Not an inversion. 1 plus 1 inversion plus 3 inversions. 5. Okay. So then I can think about 2 for 1, 0, 0, 0, 1, 1 plus 3 for 0, 0, 0. Yeah, it seems like it's true. Okay. So that is how many I would do if I did just swaps. And this is an assumption. I haven't proved it, but I vaguely remember this number of swaps equals number of inversions. Okay. Now, if I would only do only removes, I think this is a DP thing, right? I mean, not DP, but it's definitely not trivial. So I would think about it like, if I remove this, what would be the minimum number for it to be, of removes for it to be okay? And if I didn't remove this, what would be the minimum number of removes for it to be okay? So let's think about how 0, 0. If yeah, I'm gonna walk around and think about this. So I'll be back. Okay. Hello. I hope I had previously reviewed recording as well. But yeah, I was able to figure out how do you do only removes. So what you can do is let dp of I is equal to min removes to sort string I onwards, right? So if the array of I is equal to 1, then dp of I is equal to, if I choose to keep the 1, then I just need to, I'm forcing everything else to be 1 as well. So I'll have to remove all the zeros. So zeros after this, num zeros after, which I need to pre-compute. After, comma, or is the minimum of, sorry, minimum of the num zeros after, or I can choose to remove this, which will cost me 1 remove, plus, which will cost me 1 remove, plus whatever it takes to make dp of I plus 1 good, right? Yeah. And if a of I equals 0, dp of I, and if it's starting here, I don't need to worry, so I don't need to remove it, is equal to dp of I. So yeah, so you in linear time, you could figure out. Okay, so now we have what to do if you had only swaps and what to do if you had only removes. Now, how do we mix these? Curious how many sold. Oh, quite a few. Yeah, I feel this is very much within my reach. Um, hmm. So now, I claim if you ever want to do two removes to take care of a guy, you're better off doing a swap. Oh, sorry. So let's say these are the number of so we computed number of removes, blah blah blah. Um, oh, did we not have to do this whole removes thing? Is it fair to say, um, each time you feel like doing more than one swap, just remove the guy? But which guy? Mhm. Okay, let's say we compute separately the number of swaps and the number of removes. And this is confusing. I want to believe that you can do them separately because they're so close in value and find the minimum. Can I show that if you have some combination of yeah, I feel like that's the case. In any case, I'll have to code it now if I want anything to be accepted. So I'm just going to pretend that's the case. So first for swap, I'll need number of inversions. Right? So for inversions, I'm just counting. Oh yeah, I just need to count the number of ones for both things I need. Mm. Less than equal to I. Ones. Um, Maybe this is too big. -1 plus minus. Yeah. Oh, oh shit. The logic's clearly wrong because here clearly they have some mixture. Oh, in the example itself, they have a mixture of swaps for this 1001101. 1101. I remove this and this 00111, which is nice. But apparently I can do one removal and one swap. Oh, sorry, not this. 0010110. Right, here you can swap and here you can remove. It's 00. Yeah. So what I thought was wrong. So okay, what's the first idea? Okay. Quickly, we're thinking of a greedy thing. If it's just one swap, do it. If it's more than that, don't do it. Okay. So And then count number of involves. Okay, that's what I'm gonna do. And big of I minus 1 equals 1. And like in this case. No, that doesn't work. Hmm. Oh, yeah, I give up on this. Okay, this is done. Yeah, I think I'm also done. So, yep, that's it.